First up is Vincent Zimmer, and he will be talking about how Intel is harnessing this great community. Give it up.
All right, thank you. Well, thanks everyone for showing up today. I'll try not to be preachy, but in an environment like this, I'll have to fight the impulse. But yeah, I'm really honored to been invited. A lot of the community here I've worked with, and a lot of new faces. And really, what I want to talk about today is, sort of set the mood for the event, but also some of the things Intel's doing to try to help this community make it easier to do open source development. I'll use examples of some of the things we're doing within Intel. Since I want to try to catch folks up, I'm going to stop at the half hour and maybe catch questions in the hallway or afterward, if that's okay with people. So I wanted to sort of start with my beginning. Sometimes I give this talk, and I remember I once gave it, I had a picture of Rodney Dangerfield, and I said something about, firmware's the Rodney Dangerfield of the industry. Hardware people think, we're software folks. Application software people think we're hardware folks, but, didn't really want to denigrate the great stuff we do, so really wanted to sort of talk about, what motivates me, why I'm passionate about trying to open things up in my beginning. So, for me, doing firmware was, I think it was an 8085. My father had given me a board, and I thought at the time it was great. Had schematics, could wire wrap different chips, but what excited me the most was there was a book which had the source code of the monitor. So we had the double EEPROMs and actually had all the source code. And what other way to get excited about development, actually being able to touch, see how things work. And that spirit of openness and transparency over as the years have gone on and products have become more integrated has kind of been lost. And so one of the things that really, again, gets me excited about working with open source firmware communities is how can we sort of realize this again, get the data sheets, get the source code out there so people can innovate. Open up the software, and there's some business and other reasons why, but that's sort of, again, what sort of is the fire in my belly for some of this stuff. So, but as I mentioned, though, I'm going to sort of talk about some of the things Intel's trying to do here with respect to openness. And there's sort of three pillars: simplicity, openness, and then security. So really, it's not just, is the code out there? It's really, are things easy to use? Are we transparent and open to work with? And then is security top of mind of everything we do? So simplicity, we build complex code bases. Within Intel, we build a code base, want to validate all the features of a chip, sort of, we validate our hardware. It's sort of like this, very rich block. But when you go to the market, people want less. If you're building a cloud server, an appliance, an embedded system, you don't need all the features. But some of the ways today we've been delivering our code is sort of like the Jenga stack. And when you try to take features out or drivers out or recompose, it's, the stack may fall over. Some of those blocks may not be, well documented. So how can we make it easier for customers to use our code, make it simpler? And so some of the activities I'm going to talk about are really responsive to that. And then openness. Openness is not just sort of a philosophical concern. It's really thinking of what customers need. Some customers, don't want to be stuck with having to use, the supply chain, may have their own innovation they want to do. And so really giving them the pieces such that they can do what they need to do. And don't presume you know what the end customers need to do, building that full Jenga stack and assuming everyone will use it. A quote I remember from Bill Joy is, all the smartest people don't work at your company. Huge amount of, horsepower out in the industry. So how can you empower people, give them the information they need in the pieces, and not give them this sort of full stack that's kind of opaque and they can't really change? And then security from both design and development. So saying we have security features is great, but if people can't assess them, whether it's putting the documentation out there, having all the source code, really making it such that we work with the ecosystem, that it's easy to deploy fixes and patches. Security is now, top of mind for all of us. And so some of the work we do with the community here has security definitely in mind. And then what I'm going to do for the next couple pages here is just sort of highlight some of the activities we're doing. This is not meant to say these are all the open source activities going on in the industry. This is sort of just a small view of some of the activities within Intel where we're trying to act upon some of these precepts. So like simplicity, you guys are probably familiar with what we've been doing with the FSP. So trying to make it such that for code we can't put in open source, make it very easy to ingest in the open source communities. Well-defined interfaces, easy to integrate. And then on the actual platform implementation itself, later in the week you're going to hear from my Intel colleagues about this project called Intel Slim Bootloader, an alternative way to build your boot code. It leverages some of the EDK2 source code, uses FSP, but again, for certain markets, some of the embedded IoT, an alternate way to help engage that community and say, hey, can we do better? And then something we call the Min platform. So when you saw that big Jenga block and when pieces were taken out, it wasn't very clear often when we have a large code base what subset you need to build a basic platform. So what we've been doing now is creating essentially the subset of the platform code you actually need to boot, lock down some of the interfaces, have that code reusable across generations, something we're calling the Min platform. We have a few examples I've mentioned, and we're even trying to drive that concept of a Min platform even to some of our core. So a subset of code, what's the minimum you need, and it has to be open source. So everything other than FSP you can drop on top with the Min platform. And then in the spirit of that Min platform, again, openness. It's nice to have a design, but if you don't have instances of it, then it really is not worth the paper it's printed on. So having embodiments of the platform. So we've created a new project called EDK2 Platforms, where we're vying to have examples of our client, our IoT, and servers, where we build the Min platform, have the associated FSP, and have a consistent recipe that folks can look at. So if we're talking about security, and we have a security ingredient, show us sort of a full stack implementation. And the host firmware isn't everything. So you're going to hear about the sound firmware, some of the SoC firmware Intel's opening up, and then MicroPython. So tools on top of the firmware, things you can do testing and development. And then MicroPython, this environment allows us then to have tools like ChipSec, which we'll hear later in the week also, to do assessments of your platform. And this is, again, another community-based project where we'll have a tool where when new exploits come out, we can have a test to say, hey, is your platform armored against it? Or if you just want to do some general assurance work like fuzzing a certain interface, you have ChipSec. And then capsule update. So capsules there are a few things about capsules. One is the host interface. So within upstream Linux, we have LVFS, we have Windows Update, a way to send the capsule, but then the actual payload, which is a well-defined way to deliver updates. So there'll be a hackathon later in the week. And again, capsules are really emblematic of us wanting to work with the community on how to get updates out there, whether that mechanism, whether how we work on security fixes. So again, it's a journey. Argue we're not there. It'd be great if, the FSP was all in the sort of the open source column, but we're trying to make things easier. And so these are some of the precepts driving us and some of the activities sort of on that journey. And there are a lot of options in firmware. So, if this was 10 years ago, you'd see an EFI guy saying EFI or bust. And really, our view is if you're using Intel hardware, we want it to be easy to use. And there are a lot of options, and I think they're great options, rich communities like the Core Boot community, U-Boot, and Tiano Core, and really want them all to be successful and not have, I can't figure out how to make it work on your hardware, the impediment. So how do we sort of engage with all these communities? Because the market knows firmware is kind of important. The host firmware is pretty privileged. If you have your trust zone or SMM, you can cloud burst through it. If you have device firmware that's opaque to the host and has privileges. And so really being open here, not just the host firmware, but actually in the SoC, the embedded controller. I think the stuff Google's doing with its OpenEC, the new CR50. I think Facebook's going to talk about BMCs. I think it's imperative to take these precepts not just to the host firmware. We sort of fetishize and talk about host firmware a lot because it's, quote, been in the way. But, I think there was one talk Jan Mosch gave and said the Pixel book has 16 updatable firmware elements. It's not just your BIOS or your host firmware. So we care about it all. We're just trying to sort of get over that host firmware hump and make it a little easier for folks. And we do believe in openness. So this is something Stefan, myself, Mark Jones, when we wrote some stuff down a couple years ago. Really, I think the market has really spoken about open, and I think I saw some analysts said if you don't have an open source strategy, you don't have a business strategy. So I think this openness isn't just a nice to have, but really is part of doing business in the 21st century here. So I gave you the sort of the three pillars: open, simple, secure. What are some of the things we're doing? Now we have an open source core. Core Boot has a great open source core. Tiano Core does. So I think it's imperative that the core code maximize. It's open. Blobs and including that code is horrible. But our core is big. There's like 2 million lines of open source code. And so some of the things we're looking at is subsetting some of the open source packages and looking at profiles. What does it take to build a cloud server? What does it take to build an IoT? What does it take to build Slim Boot? Can we have a simpler view into the core? There's some public mock-ups we have that I talked to you guys about offline. And then the platform code we talked about, the min platform, right? What's the minimum viable product just to boot? But hey, what if you still have advanced features you want to snap in? So have well-defined packages to snap in advanced features, preferably open source. And one that we recently open sourced was the Thunderbolt code. So if you use a discrete Thunderbolt controller on Intel or AMD or other vendor, and you use EDK2, you can take them in platform, you can add Thunderbolt, and then closed source if a vendor chooses, but well-defined interfaces on how to snap them in. If you have to do binary blobs, have a well-defined interface. The original FSP, it sort of was modified for each project that used it. It didn't have a well-defined interface. We cleaved with the FSP 1.1 and now 2.0 a well-defined interface, so you can write class-like code in Core Boot or EDK2, and then for silicon-specific or platform-specific, an integration guide. So if you're going to do blobs, lock down the interfaces to make them easy to ingest, and then the build tools. If you have a lot of platform code, core code, a binary blob, but you can't finalize your ROM image, you're sort of not done. So get the tools out there. And then the last point is standards. Again, 10 years ago, this talk would have had the EFI logo and the nice line above the H. But really, standards are valuable for interoperability with shrink wrap OSs, but they kind of move slow. And so this internet age, waiting 2 years for a standard. So we're really trying to move to, if we do standards, sort of a code first, do the protocol, the interfaces, work with the community, and then if it sticks and it has value, donate it to a standard later. And then, of course, de facto standards. Interfaces that are there in communities, embrace them. So I'll pick up the pace because I want to give at 9:30 hand off to the exciting security talk. So again, here's sort of in action what I've been talking about here. Again, FSP, where we can accommodate these many communities, having this well-defined interface, this min platform where we open source the platform code, and if you have Core Boot, EDK2 full stack, Intel Slim bootloader, U-Boot, a nice way to sort of snap it in. And then again, sort of our evolution here. Have the binary blobs at the bottom, open source platform code. And then on the FSP, the one thing I wanted to share is we're trying to make it such that FSP is easy to use with both the EDK2 solution and the Core Boot. So Core Boot folks use the FSP APIs, we call it API mode. But for the EDK2, there's a lot of sort of wrappers that have to be written to use those APIs. So we're evolving FSP for something we call dispatch mode, where it just looks like a firmware volume. So we really won't have to make this strong distinction between FSPs used by some community, firmware volumes by others. I know the Linux boot folks are using the PEI FV. Let's make it a first-class citizens that you can just use FVs, and one mode of an FV can be FSP, but you can use FVs also for these alternatives. So we're trying to sort of make it such that you don't have to say FSP or binary FVs. They're one and the same. And to that end, we've been working with a lot of you folks in open compute, listening. So there's an open system firmware. So a lot of the things we've done, we've sort of, within Intel, we have one view. We build that stack, we validate our hardware, but we don't build a lot of end products at scale. And so OSF is a great place to work with Ron, Trammell, Sai, and others from the cloud vendors, security companies, and really listen to some priorities and some views on what we could do better. So I think events like this are great. Would love to have similar discussions, but we're really trying to reach out to these venues where not so much where we can sort of sell what we're doing, but sort of listen such that are we making the right investments in our time and energy. And then we have the FSP binaries, the open source code, etc. I just want to give a couple of examples in the market. So, one of the big areas where openness, it's been a little tough, are sort of our Xeon core-based servers. So last March we did open up one of these Min platforms, Mount Olympus, and on that we're really not claiming we have the ultimate, cloud solution, but we now have a baseline out there that we can iterate, open up more of the binary, provide more platform ports. And then the other thing we've definitely listened to this community is difficulties with using FSP. So a lot of folks today in sort of the existing PC ecosystem get a lot of this code, directly, and they don't really complain about issues because they get the full stack. But if you're community-based development and you don't sign the 50 NDAs, using FSP wasn't so easy. So we moved away working with a lot of our teams at Intel from click-throughs to licenses next to the file, but then we heard, some of the terms of the license were pretty tough, so we opened the license up so it's really, you can do what you want with it. You can take the blobs and put it in your own repo. And I really want to thank this community and the feedback you've given Intel. That was really helped us make the case that this had value. And again, this didn't really, change the world. As the Fornix article said at the end, it's not as good as open source, but it does show that we're listening and we're trying to get there. And with that, trying to get there, our challenges, freeing up some of the tools, our silicon code. We've heard the message loud and clear on documentation. I chatted with Trammell a little that it would have been great at the end of my talk I could say, here's a GitHub link where all these docs you were asking for. Don't have them. It takes a while, but we're listening. Debug, if we give you a binary, it needs to be easy to use, or else, again, we're not hitting that precept of simplicity. And then the rest of the platform. Don't say, if we even get everything open on the host firmware end, the journey's not done. So really looking at all of the reprogrammable micros in the platform and trying to have this precept of openness, simplicity, and security top of mind. So it's on our radar, on the books. There's that whole matrix of urgent and important. I think all of these are important, but I'd really like to hear from folks this week on what's urgent, i.e. what's blocking your getting your job done, and we'll take the action item, as we say at Intel, or action request AR, but you can give me an AR here. And sort of tying it up, again, this isn't an EFI talk, this is really a community talk, and I think all of these are first-class citizens, and we want, if you're, in my perspective as an Intel employee, want it to be easy to use Intel. And I think all of these are great and have business value, and so again, I want to work with you folks. And openness, to me it's an arc. I sort of put this page in there a lot to remind me this is where we're trying to go and haven't quite got there yet. And again, keep it simple, be open, and sort of broaden our approach for security. But I didn't really spend so much time on security because I think We have sort of one of the world's experts here to give the second half of the keynote. And on that point, I'd really like to, it's my honor to introduce Trammell Hudson, who's going to talk about firmware security and do that topic more justice than I could have ever hoped. And with that, I'd like to thank you folks.